day today, I don't think. So we're covering sections 12 and 13 today. So this is module 7, week 7 of our 16-week semester, covering just two sections, 12 and 13. I think that you'll find that this is kind of a calm week. After last week with 10 and 11, where, those web work assignments are lengthy, there's a lot to them. 12 and 13 are a little calmer than that. So just a quiz. You will have an Excel assignment. I will post a help video to go with that Excel assignment. I'm writing myself a note so I don't forget. I do have to cover a class at 1 o'clock today, so we're probably going to get out at least by 5 till so I can run upstairs and cover that class. But I will get everything posted later today, so don't fret on that. Your usual discussion board and project 2 is assigned. I will also be posting videos about project 2 so that you can kind of look through that, read through that. Project 2 is based off of CO2 production and electricity in your home. So what we're going to do today in section 12 will directly correlate to what you're going to do in project 2. So again, look for videos on that in the announcements later today, probably between 3 and 3:30 is probably when I'm going to have time to get to those videos. So there is that. Okay. Let's go ahead and get started. You will need today page 102 and 103 in your packet. If you don't have your packet with you, that's fine. You're just not going to see where we're getting some of our numbers from. But here in this first section, section 12, dealing with applications of conversions. So we're going to take the conversions, the ideas from section 10 and 11, and put them into kind of a different thought process here. So it'll be nice if you have those pages out, and we'll kind of go from there. All right, so let's go ahead and just jump right in. Of course, if you have questions as we go, throw them at me verbally or in the chat box. Either one is great, and we'll go from there. So in section 12, we are dealing with carbon dioxide emissions. So you will see on page 245, right, your yellow formula sheet. It's about 2/3 of the way down or so. You'll see two boxes. It's titled carbon dioxide emissions, and you're going to see CO2 from gas is 19. Where's my pen? From gasoline is 19.8 pounds to 1 gallon of gas. Now, what that means is that when you drive your vehicle or you run your lawnmower, or anything that uses gasoline, when you burn a gallon of gas, you produce 19.8 pounds of carbon dioxide that is emitted into the atmosphere. So when I think about driving to work, I use a little over a gallon of gas each way to get to work. So let's just say 2 gallons of gas. That means per gallon, 19.8 pounds. So if you multiply that by 2, we're at 39.6 pounds of CO2 that I produce every day coming to work just from the gasoline. So, carbon dioxide is not good, right? We all know that that's bad for us. So this is a way to kind of think about the amount that you drive. What is your carbon footprint when you drive? That is the purpose of the gasoline portion. Okay. And if I need to go into more detail, let me know. I'll try. And then we're going to talk about electricity, right? So section 12 has two parts, gasoline and electricity. And with electricity, anything that is plugged in, right, is pulling electricity. And when you use electricity, you are also, stamping your carbon footprint. So CO2 is 1.37 pounds of carbon dioxide is emitted for every 1 kilowatt hour of electricity. Kilowatt hours is how we are billed. So if we're talking about, money, the number of kilowatt hours you use is how you are billed for electricity. And then it's also can be used to calculate how much carbon dioxide you are emitting into the atmosphere. Noah, yes, you will be allowed to have that beautiful formula sheet during the test. Actually, let me rephrase that. You will be provided that beautiful formula sheet during the exam. The one that is in your packet is yours, so you're not allowed, you might have written all over that. So when you go in to take exams 2 and 3, the testing center should provide you with that exact document. So if they don't give it to you, make sure you ask them for that, because that is in the directions of the exams 2 and 3. The formula sheet is provided, and it's the exact same one. So you know exactly where everything is, what you're given, and everything. So yeah, you are not expected to memorize all of this. Okay, so these are the two big conversions, the new conversions that we are going to use here in section 12. So let's go ahead and get to the math, and we'll see what we can. Oh, wrong button. Nope. Man, I'm struggling. Okay, so I use 17 gallons of gas to get to work each week. How much CO2 do I produce? Now, some of these problems can be a little bit trickier. So I like to talk about working backwards with some of these. So because sometimes people say, well, how do I know what to use when? Which is a legit question. So when you read this and you recognize the question is how much CO2 and gasoline, when you see those two things, you know you have to use the 19.8 pounds over 1 gallon of gas. This conversion has to be used if we're talking about CO2 and gasoline. You don't have any other choice. So then you can say, okay, the question is how much CO2. So I know that my final answer is going to have a label of pounds because CO2 is measured in pounds. So my goal is to get rid of gallons because I need to reduce top to bottom, just like we did in sections 10 and 11. So that's how my 17 gallons over 1 comes at the beginning, right? That makes my gallons go away. I simply multiply straight across. And how many pounds of CO2 do I produce if I use 17 gallons of gas a week? Here we go, 336.6 pounds. Very good. Whoops, I forgot my first 6. And so if you're trying to think about how much carbon dioxide did I produce, well, 336.6 pounds of carbon dioxide, which, I mean, carbon dioxide is a gas. So when you think pounds, generally we think of weight, but because it's a gas, you don't necessarily feel it. It just is emitted into the atmosphere. Okay, did that make sense a little bit? Hopefully. Let's do one that has a little more to it. I'm going to let you guys try this one. It's a little more involved. There's an extra step with it. So I'm going to give you just a minute to see what you can do with that one. Okay, your 1 minute is up, which may or may not have been enough time. But again, just kind of thinking through this. CO2, you're talking about miles per gallon. So that lets me know that I need to use the 19.8 pounds per 1 gallon of gas. Now, when you're looking at this problem, you are given two pieces of information, 400 miles and 37 miles per gallon. And we know that every ratio can be written two different ways. So when I'm looking at 37 miles per gallon, the word per is my fraction bar. So that can be written as 37 miles per 1 gallon, or we could write that as 1 gallon over 37 miles, right? Because we can just invert the ratio. Oops, just MI. And when we have 400 miles, right, that could be 400 miles over 1, or technically 1 over 400 miles. So when I'm looking at this problem and I say, okay, the question again is how much CO2, so I know my final label is going to be pounds. When I'm working backwards from my green ratio, I have to get rid of gallons. So I'm going to use this ratio because that puts gallons in the numerator. So 1 gallon to 37 miles. That takes care of that. Well, while that's beautiful and all and gets rid of my gallons, now it has miles in the denominator, and that's not what I want. So I've got one extra step because I need to get rid of the miles, right? So 400 miles goes in the numerator, and that step causes my miles to go away, and now I'm ready to do my math. So I've got 400 divided by 37 times 19.8, which yields how many pounds of CO2? Yep, roughly 214. 0.05 is more exact, but I only had so much room. Yeah, very good. Or 0.1. Good, Shannon. Yeah, you can round, in this case, round however you want. Okay, so that's gasoline. And of course, some of them may be, if we started out with quarts or liters, you might have to change to gallons first. So there are a few different ways to kind of handle this. But for the most part, they're pretty straightforward with gasoline. I like those problems. They seem to be a little bit easier to deal with. So now let's go to electricity. And so this is where page 102 is going to come into play. And if you go ahead and just look at page 102 for a moment, 102 has a listing of a bunch of different appliances that, and their watts. Because we know, let me just write this up here, that 1.37 pounds of CO2 is 1 kilowatt hour, right? That's our conversion. So remember that we can change watts to kilowatts. That's a metric conversion, if you will. And then if we multiply by the number of hours, there is my kilowatt hours. So let me just kind of walk you through this one. I use my microwave 6 hours a month. How much CO2 do I produce in a month from just my microwave? All right, so if you look at page 102, you see that a microwave produces 1,500 watts. And from this first step, all right, so we have watts. Our next step is to change that to kilowatts. And you can do that two different ways. You can change watts to kilowatts like you did in the metric unit, where you simply move your decimal. Or you can say, I know that 1 kilowatt is 1,000 watts. If you watch any of the videos, and you should be, right? You're supposed to be watching videos. You will see that this is the method that I use in all of my videos, because we are using the factor label method throughout the problem, so it makes sense to just use it completely. Okay, so we go from watts to kilowatts. That's my first step, but you'll notice that I need kilowatt hours. So my next step is to multiply by the number of hours in question. And in this case, we're talking about a month. And in that month, we use this for 6 hours. So I will multiply this by 6 hours. Because look at what that does to my label. Now I have kilowatt hours, kWh. And that's what I want. Once I have kWh in the numerator, then I can use my 1.37 pounds of carbon dioxide is comparable to 1 kilowatt hour. So again, just like it was in sections 10 and 11, we're letting our label guide us. So these kilowatts will cancel out with these kilowatts, and these hours cancel out with these hours. Right? So it's all about canceling our labels numerator to denominator. And then we're ready to do the math. So 1,500 divided by 1,000 times 6 times 1.37. How many pounds of CO2 does our microwave produce in a month? Oh, 12.3, absolutely correct. You definitely use more or produce more carbon dioxide driving than you do by using electricity, right? It is what it is. Now I want to kind of just stop for a second. This process right here is basically what you're going to do for project 2. You're going to pick a bunch of appliances in your house, and you are going to calculate your carbon footprint for those appliances. But you're going to do that all in Excel using formulas. So we just did this by hand with a calculator. When you use Excel, Remember that Excel will do all of that math for you. So you will want to figure out how you can program Excel, well, use formulas in Excel to do this math for you. And I do have videos that I will post for that. But anyway, this is the process that you want to use for your second project. Just an FYI. All right, so just remembering watts to kilowatts, then we add the hours, then we go to pounds. That's kind of your general process when you're dealing with the carbon dioxide in electricity. And again, with electricity, we're always going to use this 1.37 pounds as 1 kilowatt hour. Okay, I want you guys to try one. This one's a little bit trickier. We got an extra layer on this one. So I'm going to give you a minute or two, see what you can do. Noah, you missed something. Hold on. Yep, I know what you did. Or didn't do. Yep. All right. So a couple things that you need to kind of pay attention to on this one. CO2 electricity, so we know we're going to use the 1.37 pounds is 1 kilowatt hour, right? You got to kind of think of that one. Then we look at electric clothes dryer. So when you look on page 102, how many watts do you start with the electric clothes dryer? Because that's kind of the first piece. If you don't have the right watts, it's going to throw everything off. And that is roughly 3,400 watts. Now, on the exam, if this problem was on the exam, it would give you the watts within the problem because you do not have access to page 102 on the exam, but you will have access to page 102 for the web work. So just pay attention to that. All right, so we know that there's 1 kilowatt hour for 1,000, or 1 kilowatt is 1,000 watts. Then we go to hours. How many hours are we actually doing this? It's 3 hours a week for a year. So how many weeks are in a year? 3 times 52, exactly. So if you think about this little side math I'm doing up here, 3 hours in 1 week, and there are 52 weeks in a year. And that's what we want. We want in a year. So 3 times 52 should give me 156 hours. Now, you don't have to do that separately, right? So I did the math up top in green. You could put those two pieces directly into your formula if you'd like, but some people like to keep it very watts, kilowatts, hours, pounds. That's up to you, how you want to kind of draw that out. It's, you know, mathematically it's the same. And then we have 1.37 pounds over 1 kilowatt hour. So again, kilowatts cancel out with kilowatts, hours with hours. And what does that give us for a CO2 for the year? Yeah, so roughly 726.7-ish, depending on how you round throughout the problem, but that's pretty close. Okay, so Noah's doing a lot of typing in the chat box. Is everybody else okay? Does anybody else have any questions, comments, concerns? We doing okay? I just want to make, okay, so Vanessa's good. I want to make sure that, oh, Vanessa has been typing in there too. Thank you for that. Good. Okay, everybody's good. I just don't want to leave anybody behind if you're confused. So thank you all for chiming in there. That's good. Okay, so we just did 2 examples of when you're actually using something, right? So when you're using your dryer, it makes sense that it draws on more energy than when it's not in use, right? So unfortunately, or fortunately, I don't know, whatever, when you aren't using your dryer, like I'm not using my dryer right now because I'm at work, but it's still plugged in. So if something is plugged in even if it's not being used, it is still drawing energy. And we call those things energy vampires, which is on page 103. So if things are plugged in but not being used, they draw a significantly smaller amount of energy. And you will see the smaller numbers in terms of watts there on page 103. So I would like you to try this one using page 103 wattages. My DVD player is on standby, which means energy vampire, approximately 20 hours a day. How much CO2 is produced in a month when I'm not using it? And pretty much anytime they talk about a month, we are assuming 30 days in a month. And definitely yes. Things that are plugged in, you're using electricity and it's costing you money even though you're not using them. Yep. So, okay, go ahead and try this one. I'll give you a minute or so. No, I don't think you changed watts to kilowatts. Your numbers are good, but your decimal point is off. Yep. That is the beauty of some of these problems. For some of it is it's very obvious depending on your answer and how it relates. It's easy for me to find the mistake. You know. All right. So again, CO2, electricity. So we know we're going to use the 1.37 pounds is 1 kilowatt hour. Not that you can read that, but just a refresher. So we're talking about the DVD player on standby. How many watts are we starting with that DVD player on standby? Because that is half the battle. No, it's not 9. Are you looking at the right page? We should be looking at page 103. There's the 1.55. There we go. So the watts on page 103. Okay, good. So because it says standby, standby implies page 103. And you'll need to know that for your web work homework. But again, if you get stuck on web work at any point in time, just shoot me an email and I can walk you through. Okay, so let me go watts to kilowatts. So 1 kilowatt is 1,000 watts. You have to have that step, right? And that's kind of your first step every time, watts to kilowatts. Then we need total hours. How many hours are we doing this business? 600, exactly. 30 days in the month, 20 hours a day. So 20 times 30 gave me the 600 hours. Now that I have kilowatt hours, then I can do my 1.37 pounds is 1 kilowatt hour. So kilowatt hours cancels out with kilowatt hours, and you should end up with 1.2741 pounds. Okay. Not much. I mean, it's not a ton, but it's more than nothing. And there you go. Okay. Yeah. Okay. How do you guys feel about carbon dioxide? I have 2 more examples, but I don't want to beat a dead horse. I don't know, that's not a very good analogy anymore these days. But anyway, you feel good? You okay with that? I do recommend, there are a few trickier ones in the packet that it might be beneficial to go over. You know, when you're watching the videos that go with the section. And especially if you don't watch the videos right away, if you do this live session first, it might be beneficial to see how much you can do in the packet and then just watch the videos as kind of a checking device. You know, you could fast forward through the problems that you got right or that you know how to do and go from there. So, okay, let's move on to section 13. Section 13 is bar graphs and histogram. I think that you guys are going to like this section because I think it's a little bit more straightforward. There's not as much I don't know, thinking, for lack of a better word. The big thing that we need to talk about is the difference between a bar graph and a histogram. Because while they are very similar, they are also very different. So a bar graph, I think you can all picture a bar graph, right? We've got bars. So this would be an example of a bar graph. Not a good bar graph by any chance, but a bar graph. You will notice that in the bar graph that I just did, there are spaces between the bars. Okay, so there must be space between the bars in a bar graph. And the reason that is true is because a bar graph represents categorical data. Categorical. Meaning, if I went to a car dealership and I wanted to graph the color of cars on that lot. So I have blue cars and green cars and yellow cars and orange cars and white cars. There's space between them because when the bars touch, that implies a smooth transition. There's not a smooth transition between an orange car and a white car. You're either orange or you're white, right? There's no in between there. Each color is itself its own thing. So when you don't have a common flow of data, the bars have to be between. Another example would be the number of runs scored in a baseball game, right? I can score 0 runs, 1, 2, 3, 4, 5, 6. I can't score 2.5 runs. So these bars could represent 0, 1, 2, 3, and 4. There's space in between because between 2 and 3 is 2.5. If you can't score 2.5 runs, then you can't have touching bars. Do you see what I'm saying? So the categorical is when there is space between data points. That is the purpose of a bar graph. Then we go to a histogram. A histogram is a type of bar graph, but as you can probably guess, the bars touch. So you can see how they share a common side. Again, not a beautiful bar graph, but you get the picture. So there is a common flow. So ages would be a histogram because, you know, I turned 36 in October. I will be 37 next October. Well, okay, it's February. How old am I now? I'm, 36 and 2/3, whatever. There's no like concrete day of this is when you turn 37. Well, if you round up, on April 13th, I'll turn 37 because that'd be 36 and a half and it rounds up. So there's no concrete, there's space in between. So age, right? Anything that's time related, time is continuous. Histograms deal with continuous data. So continuous, there should be another U in there. So because age is continuous, time is continuous, volume. Think about your water bottle. I could have 1 ounce of water. I could have 1.2, 1.3, 1.4, 2.5. If you can have decimals and fractions as part of your data, then it's continuous. And if you have continuous data, then you have a histogram. So there's no space between the bars because it's constant and it flows. Okay? I hope that makes sense. Do you see the difference between them? I hope. Okay, and then I have watch the video that goes with page 111. Obviously, I think that's important. We're going to do kind of an example here now that's similar to that, but I don't think it's as intense maybe. So I guess I recommend that you do that. Well, I guess I find that important. Who knows? I do think it will help you with a web work question. So let's, that may help too. Okay, so now let's actually get to an application of these. So we're going to create a graph that goes with the ages of participants in a talent show. So I give you here 20 ages of participants in a talent show. Are there only 20? 6, 7, 4. I think there's 28. I don't think that's what I have down. Okay, great. So 28. And we want to create a graph. Are we going to create, first of all, a bar graph or a histogram? That's my first question to you. Talk about ages of people. Everybody thinks a bar graph and not a histogram. Nobody wants to say histogram? Dang it, all my stuff is already gone. I forgot about that. Okay, thank you for saying histogram. That was great. Yes, you're wrong. Yes. So remember, think about what the data, we're talking about ages. When you go from 4 to 5, we're talking about, these are young people, 4 to 5, you have 4 point, you become 4.5 years old, 4.3. It is a histogram because the ages meet, yes, because it flows, right? There's not a distinct difference. When you think about cars in a parking lot, red and a blue car, those are not the same. They never converge. Those are two very separate things. But when you're talking about your age goes from 4 to 5 seamlessly, right? There is no concrete difference between them. It just goes nicely from one to the other. So because it flows, this is continuous data, right? Your age is continuous. That is why we will have a histogram. So when we graph this, you want the bars to touch. Now, I'm not going to tell you how to create a bar, because a histogram is a type of bar graph. So technically you weren't wrong, but you needed to be more specific. So you'll notice that 3 is my youngest age, and there are 3 of them. So when I graph this, my bar for 3 needs to be 3 high. And then I look at my 4s, and how many of them are there? So you want to make sure that each number is represented in your bar graph. And here is an example of a histogram for that data. All right. Now, if we just talk about this for a moment, notice how the bars touch. And yes, in Excel, there is a way to do this. Obviously, that's how I created this one. But it's not intuitive. It takes a lot of clicking. That is why I will post the video of how to do this in Excel, because it can be very frustrating. I've done a lot of cussing and threatening to throw my computer playing with Excel, and I do not want you to have that same frustration. So you can build this in Excel, and you notice the bars touch. And you can see, right, 3 is my ages. Your continuous data is what's going to be on the horizontal axis. So my lowest age is 3, and there were 3 of them. That's why the bar is 3 high. And it goes in order. If I had an age that had 0, you still need to include that. It would just be a bar that's empty. Okay, but you need to have all of them. You can't just skip spots that aren't there. All right. You will notice the label on the vertical axis here is frequency, right? The definition of frequency is how many. So we want frequency to be our vertical axis because that shows, there are 3 people here. There are 1, 2, 3, 4, 5, 6 people in the 4s, and that, whatever. Okay. So there you go. And you should always have a title in your graph. All right, so in your packet, there are multiple ways of graphing, and you do want to practice that. And Crystal, yes, you can use numbers instead of Excel. I really don't know how to do it in numbers. The only thing is sometimes it takes me a little bit longer to grade those because I have to grade those on my iPad, but totally fine. Absolutely, yeah. I think you can also use Google Sheets. Because I think that's also a spreadsheet of a type, but again, I don't know how to help you there either. And I think with Google Sheets, you have to I have to open that in my Gmail, which totally can be done as well, right? We can make all of this work. So yeah, use whatever spreadsheet you want. But I'm sorry, I can't help you with any of the other ones. But I'm sure YouTube can, right? So rock it out. Yeah, do it. Do what works for you. Okay, I do want to answer 2 questions. Well, actually 3. If you look up above, we want to find the mean and the median. And then what does that tell us about the distribution? So, yeah, amen on that. Bless the internet. So if we think back to section 8, and I know that was a few weeks ago, but in section 8, we talked about if the mean equals the median, then we have symmetrical data. And if the mean is greater than the median, we have skewed right data. And if it's skewed, that kind of thing. So that's what we are trying to figure out. Now, from this histogram, we can find all of this information. You could take the 28 numbers that we had on the previous page and put them in order least to greatest and do all of this by hand. But I don't know about you, when I'm starting to play with 28 numbers by hand, I'm going to probably make a few mistakes because it's easy to lose a number here and there. So I just want to show you kind of an easy way. Yeah, you have the graph in front of you. Yeah. So let's say that you're given this histogram and you want to find the mean and the median. We can do that from this histogram. So remember, to find the mean, we need to add all of the numbers up and divide by how many we have. Well, we know there are 28 numbers total. So we know we're going to divide by 28, excuse me. Okay, so think about this. If I have 3-year-olds and there are 3 of them, then this box here has 9 years in it, right? Because there are 3 3-year-olds. So 3 times 3 is 9, right? Then if I go to my 4-year-olds, okay, so if I'm talking about this box here, I have 6 4-year-olds. That's 24 years total because 6 times 4 is 24. Stop me if this doesn't make sense. Then I go to my 5-year-olds and there's 7 of them. So 5 times 7 is 35. This is going to test your multiplication skills. Now I have 2 6-year-olds, that's 12. I have 5 7-year-olds, that's 35. I have 3 8-year-olds, and I have 2 9-year-olds. Shannon, we're talking about age, right? These are the how old they are. If you think back to that previous page, there were 28 ages of people. So when we're trying to find the mean, we're trying to find the mean age of these people. So if they're 3 years old, 4 years old, 5 years old, we need to find the average age. So I'm multiplying these to say, if I have 3 3-year-olds, I'm putting them into groups, right? So I'm putting all my 3-year-olds, my 4-year-olds, they're all together in age groups. And then I'm figuring out how many of them are there based off the height of the bar and the frequency. Yes, so instead of adding them one by one, I'm putting them into age groups and I'm adding them by age group. So now instead of adding 28 numbers together, I can just add 7. And I don't know about you, but I'm less likely to make a mistake in my calculator with 7 numbers versus 28. Right? You're less likely to skip one, enter something in wrong, whatever. So if I add those 7 numbers together, 157. Thank you. So if you think about the total ages of all 28 of these participants is 157. That's their total years. And because there's 28 of them, when I divide by 28, what is the average age of these people? 5.6. Okay, very good. Any questions on how I did that? Right? And here's the thing, if you have the 28 numbers and you feel comfortable adding all 28, well, then do it, right? Mathematically, it's the same. This is just kind of, especially if you're given a graph, this is a little bit easier to do. Okay, so we know, let me erase that. We know that the mean is 5.6. All right, now let me show you, this is super fun, how to find the median, right? Because remember, by definition, the median is the number in the middle. And you can't just say, well, it's 6, because 6 is, if I look 3 to 9, 6 is in the middle. No, that's not how this works, because I have 7 5-year-olds, right? So you got to think of each one of these blocks as a kid. So if these kids are in order, all 28 of them, we need to find the middle kid. And the way we found the median, think back, is we crossed out a small number and a big number. So I would take out a 3-year-old and a 9-year-old, right? Because I'm working my way to the middle. And then my small number and my biggest number. Because there's no vertical lines, this is a little bit harder. The video that I have on this works a lot better. But you can see now that my 9-year-olds are all taken care of. I still have one more 3-year-old, and then I have an 8-year-old. And I'm just working my way to the middle. Now I go to my 4-year-old, and I still have an 8-year-old. I'm trying to, I have another 4-year-old, there's another 8-year-old. So you can do this one at a time, or you could say, okay, I have 2 to 6. This is 1, 2, this is 4 4-year-olds, 1, 2, 3, 4. There's 4 7-year-olds. So you can kind of do it chunks at a time if you would like. I have one more 7-year-old. Let's take out one 5-year-old. And then, so orange is not going to be a good color. And then if I have 2 6-year-olds, I could take out then 2 5-year-olds. And look what I have left. Right? I have this big chunk of space, and if I divvy them up into smallest, biggest, my 2 kids in the middle are both 5 years old. That means my median is 5. So by using, just like we did when we had the list of numbers in order, we crossed out the biggest number, the smallest number, biggest number, smallest number. We're doing the same thing, but we're marking out boxes representing numbers instead of the actual numbers. Okay? So hopefully that makes a little bit of sense. Again, the video from page 111 will be more work with that. Okay, now we can do our comparison. If the mean is greater than the median, because 5.6 is greater than 5, what does that tell us about this distribution? Is it symmetrical, skewed right, or skewed left? Yep, you guys are right. It is absolutely skewed right because it's pointing to the right. Right? We talked about how whichever way this points, that's the way it's skewed. So it's skewed right. And now, if I could, I'm going to clear this. Another way to kind of look at this, find the tallest bar. So this right here is my tallest bar. When you're looking at the graph and your tallest bar, if I look to the left of that, I have 2 numbers. Put it up here, you can see it easier. When I go to the right, I have 1, 2, 3, 4 numbers. So you can see how it will tail farther this direction because there are 4. That also shows me it's skewed right. So if you can find your tallest bar and look which side has the majority of the data points, that's the way that it's probably going to be skewed. And go from there. Okay, that is the end of section 13. So we've got a few minutes left. If anybody has questions, does anybody have any questions about sections 12 or 13 at this present moment? All right. Why is that on here? Okay, then the only thing, what class are we in? This is CBB. Since I have just a few seconds here left, I kind of just want to point out project 2, where to find it. So we're in module 7. Here we go. Okay, so you've got web work 12 and 13. Here's your Excel assignment, your quiz, your project 2. So just to kind of point it out, so none of you, here it is. I know it says fall of 17, but just pretend it says spring of 18. And get on the right page here so you can see it. So you're going to have your spreadsheet 1. You're going to label it. You've got your pieces. I don't think those might be the right pages. But this is everything that you have to do. And again, I will have a video for this. But I want to point out that this is spreadsheet 1. So you're going to do all of this work in your spreadsheet on the first one. And then you're going to copy that entire piece and put it onto spreadsheet 2. Because in spreadsheet 2, you're going to reduce your CO2 production. So, I'm giving you a little hint here. You want to reduce it by 2,000 pounds a year. So you want to pick some appliances that use a lot of electricity. So pick the biggest ones you can find off of that page that you use a lot, because it's a whole lot easier to reduce if you start with a huge number. So pick some big ones. So your first spreadsheet is going to be everything that you're using, and then spreadsheet 2 is going to have all of your changes in it. So again, read through this. There's a lot of pieces. And in true project fashion, you're going to have a reflection paper. So after you do the Excel, you're going to write about it in your reflection paper. So just like with project 1, if you want me to check your Excel document first, I am more than happy to do that. You just need to send it to me. And we'll go from there. So project 2 is due, where does it say? April 2nd. So you want to have it done, but April 2nd is the due date, which means you have all of spring break to work on it. So that's kind of nice. And just in case you haven't done project 1 yet, project 1 is due on March 4th. So project 1 is coming up, maybe it's March 5th. I'm guessing it's Monday. So project 1 is probably due next Monday. So you want to have that done. If you haven't started working on project 1 yet, I recommend you do that now. Get that taken care of. And again, if you want me to check your Excel spreadsheet, go ahead. And we'll go from there. So project 1 is under module 4, in case you forgot where that was located. So Noah just asked about the dosage papers. How well did those go for us as a class? Noah, that's a fabulous question. I haven't graded those yet. I graded everything else yesterday, and I didn't have the answer key of that with me at the time. It was in a folder in my apartment, and I did nothing last night because I was lazy. So my goal is to get those dosage calculation papers graded either today or tomorrow. But I anticipate them going very, very well. Usually they're pretty good. So look for those to be graded in the next day or two. Yeah, sometimes I'm lazy. It happens. I'll own it. Yeah. But everything else should be caught up. So I think we should be good to go there. So yeah. Any other questions for me at this time? All right. Well, if we don't have any more questions, then we're going to call it a day. Next week, we'll do sections 14 and 15 and kind of prepare for spring break, which is awesome. So that is super good. And yeah, we'll go from there. So keep working hard. Keep emailing me with questions. I appreciate when you do. And thanks for giving me an extra couple days grading those dosage papers. And if you need anything, you know where to find me. So have a great week, and I will see you guys next Wednesday. Have a good one.